Hello, today we're going to look at the topic of multiplication of large numbers. Hopefully we understand that multiplication is a form of repeated addition, but when we're dealing with large numbers, it doesn't make sense to add up the numbers repeatedly. So for example, when I say that, I mean when I say 3 times 4 or 3 groups of 4, I could think of this as being 3 repeated 4 times and added together. Or I could think of this as 4 being added together 3 times. And both ways we get that the answer is 12. So when we have small multiplication, we can use processes like these to get to the result. But if I try to multiply something much larger, let's say 89 times 27, well, it's not going to be easy to add 89 27 times or 27 89 times. And so it's really important to understand what's called the algorithm of multiplication with large numbers. Now, algorithm is just kind of a fancy name or word for process. So we're going to look at an example. Here we go. This is taken from Alex. So we have our problem here. Now you always want to make sure you look carefully at the instructions. Now this instruction is quite simple. It just tells us multiply, but sometimes the instructions give us much more details about what we need to do. So we're multiplying 738 times 39. So I'm going to go through the process and explain the process as I go. So essentially what we're doing is we're breaking up 738, and we're breaking this up into two parts. We're first saying 738 times 9, and then 738 times 30. So I'm going to kind of break this down to show us what's happening. 738 times 9 is the first step, and then 738 times 30 is the second step, and then we combine them together and add those two together. I think it's really important that you understand that because there's something kind of interesting in this process that we do, and it's important that you understand why we do it. So another thing to note before I get into this multiplying is that it's super important that you know your multiplication facts. And you should know them by heart. And if you don't, I have some materials in Blackboard that you might be able to see and use to get better at it. You can practice on your quick tables. I also potentially might be getting some really cool virtual multiplication facts cards that might help you learn those facts. But it's really important because when we look at this, what we're doing is we're taking each digit here and multiplying it times that ones digit. So we're going to do 8 times 9, which is 72. So I'm going to write that up here. 8 times 9 equals 72. So this value we get, 72, has a ones value and a tens value. So the ones value goes below, and the tens value gets carried over to the next step because those tens need to be added in to when we multiply the tens here times the ones. So the next step is going to be to do the 3 times 9, which is 27, and then we add in the 7 that was left over from here. So 27 plus 7 is 34. So again, we're going to bring down the 4 and we're going to carry the 3. Okay? And then we're going to do that same process. Now we're multiplying 700 times 9, but we treat it as 7 times 9. So 7 times 9 equals 63. And 63 plus that 3 we need to add in equals 66. So now there's not another digit here to pull or add those 6's in the tens place there too. So what we're going to do is we're going to bring both down, and that's going to be 66. Okay, so that's our first step. So when we get this row here, that's coming from these individual digits being multiplied by that ones place. Okay, and then remember, you always bring down your ones place and carry the tens. Multiply, 3 times 9 is 27. Add in the 7, which gave us 34. We write down the 4 and we carried the 3. Then we do the 7 times the 9 to get 63. We add in that 3 and we bring down the 66. We bring down both because there is nothing else in that thousands place to multiply. Okay, so that's that first step. We took the top value, 738, and we multiplied each digit times 9. Now we're going to have to multiply each digit from the top times the value 3, which is in the tens place. So you really need to understand that that's not a 3, it's a 30. Okay? So when we think about that, we're not saying 8 times 3. We're actually saying, it's not 8 times 3, it's actually 8 times 30. 8 times 3 is 24. So 8 times 30 would be 240. It just adds that 0 on the end. And that's going to typically happen. So what happens here, and the way we treat this, is that we actually just automatically put that 0 here to recognize that I understand that this isn't just a 3 here. This is a 30. So I'm already going to address that 0 from the get-go, and now I can treat this as 8 times 3, which is 24, and we carry that 2 up. And then I do the same thing, 3 times 3. We know it's not a 3, we know it's a 30, and we know this is a 30 as well, but we've already addressed that by this shift with that 0 there. So 3 times 3 is 9, plus 2, so 3 times 3 is 9, plus 2 is 11. We bring down the 1 and carry the other one. So this is the one from the ones place. This is the one from the tens place. Then we do 7 times 3, which is 21. And then we add in that 1, which gives us, it won't let me do it, which gives us 22. There's no other digit here, so we bring both down. Okay, so here's what's interesting about this step. When you see the algorithm, when we shift over to here, they automatically put that 0 there. That's to indicate that we moved over to the tens place, and we're treating this like it's a 3, but it's actually a 30, and that's the value, that 0 there, that treats it like it's a 30. Okay, so for this portion we got, okay, so then we've broken this into 2 parts. We found the 738 times 9 and the 738 times 30. And so now what we need to do is we combine those 2 results together, because 30 plus 9 is 39. So if we're trying to figure out the total for this multiplication, we've broken it into 2 parts and need to combine them together. So we end up adding starting from the right. 2 plus 0 is 2, 4 plus 4 is 8, 6 plus 1 is 7, 6 plus 2 is 8, and then 2 plus nothing is 2. And that is our answer. There is another method you can use to multiply large numbers. That's called the lattice method. I will show you how to set up the lattice method for this problem, which was 738 times 39. I'm going to write that over here. Okay. The lattice method, it refers to the design method of solving this. So what we do is we look at this. This number here has 3 digits. It has a ones, a tens, and a hundreds. So it's 3 digits. This number here has 2 digits. And so with the lattice method, we create a box. And because this top number had 3, we break the box into 3 parts for that value, for that number. And then because the second number, 39, has 2 digits, I break that into 2 and write down the number 39 on the right-hand side. So the first number, the top number, goes in the top, 3 digits. The bottom number has 2 digits and goes on the right-hand side. Now what we then do is we take each of these boxes and we divide them in half diagonally from the top right to the bottom left, like this. Because what we're essentially going to be doing is we're going to be multiplying each digit times each other, and when we get a tens, the tens will go in this red side, and the ones from our multiplication will go in this purple side for each one of these. So top half will be our tens, the bottom half will be our ones. Okay, so let's start. Let's start first by doing 7 times 3. 7 times 3 is 21, so the 2 from the 20 goes here, and the 1 goes right there. So 21. 7 times 3 is 21. Then we do the next one. 3 times 3 is 9, so there are 0 tens and 9 ones. 8 times 3 is 24. So the 2 goes in the top, the 4 ones goes in the bottom. 7 times 9 is 63. 3 times 9 is 27. And 8 times 9 is 72. Now, so we've multiplied each digit time of the first value times each digit of the second value. Now, if you remember, when we multiplied before, when we got the first row, we multiplied, and then the second row, we multiplied, but we started with a 0 to shift over because this is in the tens. The lattice method automatically allows for that shifting because the way we add up these digits is diagonally. So we get that shift. This diagonal that I'm going to put a little star next to, that diagonal represents my ones. This diagonal represents my tens. This diagonal that I'm circling now represents my hundreds for my result. Okay, and so forth, so on, thousands and 10,000s. So when we add each of these diagonals together, we'll get our solution, but we might have to carry over. If we have more than 9, we have to carry over to the next column, just like we do when we add. Okay, so 2 plus nothing is just 2. 7 plus 7 is 14. 14 plus 4 is 18. So I get the 8, and I have to carry the 1. I'm going to do that in purple. The 1 has to be carried over to the next column. So this is going to be 3 plus 2 plus 9 plus 2 plus 1. So 3 plus 2 is 5. 5 plus 9 is 14. 15, 16, 17. So for that hundreds column, we get a 7, and we carry our 1. Then we have 6 plus 1 plus 0 plus 1. 6 plus 1 is 7 plus 1 is 8. And then there's nothing to carry over, so all we have left in that 10,000s is that 2. So our answer is still 28,782, which is the exact same thing that we got in the other method. So both of these methods are possible to use for multiplying large numbers. Thank you.